Alright, so welcome back. So what we're going to do today is we're going to introduce the Zener Diode. So Zener Diode is going to be broken up into two sections. The Zener Diode is going to come in the form of a DC circuit and an AC circuit. So we're going to start out as DC and then move into AC. But for this video, this is just going to be an explanation of what the Zener is and what it's generally used for. All right, so looking at the Zener Diode. So this is the schematic symbol. So it's very, very close to the diode schematic symbol. However, it's got the additional little lines right here. So on a schematic, if you see a diode symbol with these lines here, in addition, that is indicating that it is a Zener diode. Okay? So the actual component, here's my horrible drawing, but I'll actually show this to you once you get into class. But the diode itself, mostly your Zeners are going to be red colored and almost transparent, kind of a red transparent, and at one end of it is going to have a black stripe. Okay, so just like our regular general purpose diode, here's our anode and here's our cathode. We still have the anode and cathode. So on your actual component, the striped end is going to indicate the cathode, and the non-striped end is going to indicate your anode. So it's the same thing with your general purpose diode, except general purpose diodes are generally black with a silver stripe. And I think I mentioned that quite a few videos ago. But it's the same thing. Striped end is cathode, non-striped is anode. So that's just a common thing across the actual components of a diode, is your striped end indicates your cathode. Okay, so a Zener diode has some characteristics a lot like a general purpose diode. However, it has one key difference, and that's what we're going to go over today. So, forward bias, again, is always going to be anode is more positive than the cathode. Always. So if your positive is at your anode, and your negative is at your cathode, that means that it's forward bias. So, when a Zener diode is forward biased, it's going to act just like a general purpose. Easy as that. So that means that when the Zener is in forward bias, once it reaches 0.7 volts, it locks there and it starts conducting. So in forward bias, you treat this just like we've been treating diodes. Easy as that. So forward bias, it acts like a general purpose diode, locks at your golden 0.7 volts number. Okay? Where it becomes different, and also I want to state, so prior to getting that 0.7 volts, acts like an open, just like a general purpose diode. So here's the difference. In reverse bias, it will remain open until you reach what we call VZ, which is the Zener's reverse voltage. So a Zener is going to be used in all of your electrical circuits, because what this is used for is a voltage regulation. There is no set number. Zeners come in all different values, everywhere from a volt up to 200 volts. And what it is it's used to be a voltage regulation. For instance, your phone chargers. Your phone's charged at somewhere around 5 volts and some change. So somewhere in that power supply, there's a Zener that is locking that at 5 volts. It's used to regulate whatever output you want. And that is what a Zener's job is. So it blocks current one way until it reaches Zener voltage, and then also it'll allow current 0.7 volts when it's forward bias. And I think this will make more sense once we actually put it into a circuit. So for now, just remember forward bias, it acts like a general purpose diode, and reverse bias, it locks at what we call VZ, which is the Zener voltage, and this voltage varies. Okay, so the VZ will be marked on the package, and it's also identified by a part number. So you can always have that readily available. You can Google the part number, and all you got to do is go down and find that VZ number, and that's what it will lock at when it's reverse bias. Okay? So again, this is used mostly in all of your electrical circuits as a means to regulate what your voltage output actually is. Okay? So, forward bias locks at 0.7 volts. Reverse bias locks at whatever the VZ value is. Until it reaches 0.7 volts in forward bias, it's an open. And until it reaches VZ in reverse bias, it acts as an open. Okay? So it kind of doubles as a Zener and a general purpose diode, depending on which way it is pointing. Okay? So again, this is kind of a short video, just giving you a brief explanation of what a Zener diode is. So most importantly, what your schematic symbol looks like and how it acts forward bias and reverse bias. Okay? So the next video is going to be a chart with a varied voltage, just like we did when we first started diodes. Okay? And then we're just going to look at what it would look like with a Zener diode instead of a general purpose diode. Okay? So that's coming in the next video, so stay tuned.